Hi everyone, my name is Kevin Brown, and the date today is May 22nd, 2020, and today I'll be presenting on my Unit 4 case connections. Considering the newborn girl's case, a diagnostic that would be best to distinguish between a urea cycle disorder and a disorder in beta oxidation would have to be answer D, plasma glutamine. This diagnostic easily provides a noticeable contrast between our two disorders in question. We know that glutamine is a nitrogen-carrying transporter in the bloodstream. This would be indicative of this particular amino acid circulating in the blood. If a disorder in the urea cycle was noted, we would see an inefficient conversion of ammonia to urea. Because of the continual creation of ammonia from deaminations and protein catabolism, the toxic ammonia is commonly transported through the blood by glutamine. As a result, glutamine then administers ammonia to the urea cycle. In a urea cycle disorder, we would see an elevated level of glutamine coming from higher levels of ammonia, and the urea cycle functionality would be reduced. In regard to a beta oxidation disorder, we would notice an inhibition of gluconeogenesis and diminished energy of fatty acid oxidation. This is because the body would be in a phase of utilizing glycogen stores and amino acids, which are then converted into intermediates in the TCA cycle. As a result, this amino acid catabolism increase would give way to lower plasma glutamine levels in a patient with this type of disorder. We can easily rule out answer A, blood glucose, because a blood glucose diagnostic would measure blood glucose levels and its utilization and production. A urea cycle disorder would result in a deficient conversion of ammonia to urea, which is then excreted out of the body in the urine. We would see a large formation of ammonia and upstream intermediates. While it is good and necessary to elevate blood glucose levels in diagnosing and treating various diseases, this would not be a good diagnostic for distinguishing a disorder in the urea cycle. We know that a disorder of fatty acid oxidation results in hypoglycemia because gluconeogenesis requires ATP, along with allosteric activators from this type of oxidation. However, it is my opinion that this blood glucose test would also not be able to accurately diagnose the problem as solely being a beta oxidation deficiency. This newborn baby girl could have a number of issues relating to other causes, and it would be hard to pinpoint whether it was either of these disorders. Moving on, we can also easily rule out answer B, urinary acids, because this type of diagnostic test would examine amino acids in the urine, and urea cycle disorders could produce orotic acid in the urine, but so could a number of other deficiencies not mentioned, particularly pyrimidine synthesis deficiencies. I believe that looking at urinary acids would not be advantageous because it does not help decipher between the two disorders. Finally, we can rule out answer C, serum fatty acids, because this type of diagnostic would tell us the amount of free fatty acids in circulation throughout the body, and it won't necessarily indicate healthy or unhealthy urea cycle functionality. These types of fatty acids tell us about the availability of fatty acids for uptake and oxidation. However, they will not be helpful in deciphering beta oxidation of urea cycle disorders. In order to answer the second part of this case study, we must look at the results of the blood work. Based on the rapid increase of blood ammonia from 314 micrograms to 600 micrograms, elevated levels of urine orotic acid, and normal levels of plasma citrulline, we can draw some conclusions. These conclusions would be that the enzyme that is least likely to be impaired in this scenario is carbonyl phosphate synthetase. We know that there has to be a way that carbonyl gets synthesized. The elevated levels of orotic acid can be indicative of a synthesis of carbonyl phosphate. We can come to this conclusion because in pyrimidine synthesis, the upstream substrate from orotic acid would be carbonyl phosphate. We can also note that because plasma citrulline levels remain relatively normal, this would signify something is happening upstream of citrulline. Moving on, the most likely urea cycle enzyme deficiency would have to be an enzyme between plasma citrulline and carbonyl phosphate, which I would think would be ornithine transcarbamylase, OTC, also also called ornithine carbamyltransferase. A deficiency in OTC is actually an inherited disorder, which is amplified by an accumulation of ammonia in the blood supply. And after looking at the patient's blood work that was done, I think this would actually be really indicative of this. So I think that's definitely a possibility. Moving on to case number 3, a 47-year-old man has presented with severe pain coming from his right big toe. Based on his abnormal levels of plasma urate and urinary uric acid, as well as his physical exam, he is diagnosed with gout. We are to come up with the best explanation for his presentation of gout and explain why the other options are not plausible. In this, we're actually given 3 options: overproduction of purines, decreased salvage of purines, or decreased urinary excretion of uric acid. We know that an overproduction of purines would result in higher levels of degradation of excess purines. Since the final product would be uric acid, it would then be transported and excreted in the urine out of the body. With an overproduction of purines, we would also see higher plasma urate and higher uric acid levels, but this 47-year-old man has low uric acid, so I think it's safe to rule this option out. A diminishing of the salvage of purines signifies that there would in fact be an increase in purine degradation, because pure purines would be recycled. Consequently, this would lead to an accumulation of plasma urate and urinary acid levels. However, our patient does not exhibit elevated uric acid. Based on his results, they are significantly lower than normal, so therefore we can rule out that option as well. In regard to decreased urinary excretion of uric acid, I believe this will lead to an accumulation as well. This arises from lactic acid competition when dealing with excretion. However, this is more closely associated with excess alcohol metabolism, and that's not one of our options. One possibility, as we look at the patient's results, could be a malfunction in urate transporters. If we saw a decrease in urinary excretion of uric acid, it would only make sense to also see higher levels of plasma urate in conjunction with lower levels of uric acid. Based on the patient's results, I would say this is a plausible diagnosis. The patient further tells us of his switch diet to regular soda, and the fact that he partakes of 4 to 5 liters of soda every single day. We are to answer what we think could be a potential impact of this dietary alteration in regard to his diagnosis of gout. The amount of high fructose intake every day will inevitably lead to increased degradation of purines. This fructose is quickly absorbed in the cells from fructose kinase. In the glycolytic pathway, fructose is to be divided by aldolase B. However, this produces a buildup of fructose 1-phosphate. This leads to a reduction of ATP and free phosphate, but overall leads to a raise in AMP levels. Through this process, AMP deaminates and is converted to IMP, which ultimately increases purine degradation. That is the potential impact on the presentation of the patient's diagnosis of gout. This concludes my presentation. Thanks for watching, and aloha.